we were discussing about the system of circles. So in the system of circles, so we have discussed some of the basic concepts. If you extend that discussion, so there is one theorem that you can note down. If S is equal to, if S is x square plus y square plus 2gx plus 2fy plus c equal to 0. And this is the equation of the circle, and Lx plus my plus nz equal to 0 represents a straight line. Then intersecting each other, then the equation represented by so S plus K times of L equal to 0 represents a circle passing through the intersection of the circle S and the line L, right? So this is the theorem. So what it states is, suppose if you take one particular circle, so let us say this is the circle, and then there is one straight line which is intersecting with this particular circle. So this is the straight line, and this circle is represented by S equal to 0, where S is given by x square plus y square plus 2gx plus 2fy plus c equal to 0. This represents the equation of the circle, and the equation of this straight line L is given by Lx plus my plus n. So Lx plus my plus n is equal to 0. So this is Lx plus my plus n, simply n, equal to 0. So this is one particular straight line equation. Now there is an intersection point of these two. So here it is intersecting with the circle, and here also it is intersecting with the circle. Now what we are interested is, if there is an equation S plus some K times of L equal to 0, and this equation represents a circle. So this also represents a circle passing through the intersections. So this is the statement. That means, so that equation is representing one more circle, but passing through these equations. So this is how actually the equation is going to be. So this equation is, so this is, so S plus K times of L equal to 0. So this is the problem statement. Now to prove this, now we have the information. One is S is equal to 0 is the equation of the circle, and Lx plus my plus n is equal to 0 represents the equation of the straight line, and there is an intersection point. Let us say this intersection point is x1 comma y1, and this intersection point is x2 comma y2. Now if you talk about S plus K times of L equal to 0, where K is any real number. So K is any real number. Hence actually K, you can select any value of your own interest. So this K value, once you select it, if you put it, then actually S plus KL is equal to 0. Now in this equation, if you notice this equation, so S actually if you substitute it, x square plus y square plus 2gx plus 2fy plus c plus some K times of Lx plus my plus n equal to 0. Now if you notice, this equation is a second order equation. And that second order equation, if you notice, this is x square plus y square plus 2gx plus 2fy plus c. And in this, even if we add this value of k times of lx plus my plus n, there is a change in the value of this g and f and c. There is no change in the values of x and x square and y square here. So that means this still represents the circle, but the center of the circle is going to be deviated and the radius is going to be of the changed value when you add the value of lx plus my plus n into k. So this is the only portion actually. Yeah. So this is the only portion actually. So which is intersecting with this particular region. So hence actually we can conclude that as it is in the standard form of the same circle equation, x square plus y square times of some 2g dash into x plus 2f dash into y plus c dash. So that is the new circle equation represented by s plus kl, because this l is added to this 2g and this n is added to this 2f and this n is added to this c. So hence actually the value of the center and the radius is going to be changed for the new circle. Now it still represents the circle. So one conclusion is made, that is this equation s plus kl is represents a circle. So this is representing the circle. And this conclusion is more. And the second important aspect that you need to prove is, and he states that in the statement, the new circle which is given by s plus kl equal to 0 is even passing through the intersection point of the previous case, that is the original circle and this particular straight line. So this equation actually, if you notice, let us consider x1, y1. So x1, y1 is the intersection point of the straight line and the first circle, s is equal to 0. Now this equation x1, y1, if you substitute in this, and this is x1 square plus y1 square plus 2gx1 plus 2f, so 2gx1 plus 2f(y1) plus c equal to 0. And this value actually, you know that s11 is equal to 0 because this value lies on the first circle. So this portion actually states that as this point lies on this first circle, hence actually the substitution of that point actually will make the value to be 0 because this is satisfying the circle equation. And the same point is even on this particular line also. Hence actually, if you substitute the x1, y1 value in this straight line equation, still actually this equation is getting satisfied and the equation of this straight line is lx plus my plus n is equal to 0. Hence actually, this is lx plus my plus n and this is still being 0. Now if you notice, this 0 plus k times of 0 is still 0. So hence actually, you can conclude that this point lies on the bigger circle which is given by s plus kl is equal to 0. So we proved that this equation or this point lies on the second circle also. That is important to understand. And the same kind of analysis even we can do even for the point of x2, y2. And for the point of x2, y2, this point lies on the straight line and this point lies on this particular circle as well. Now, if you substitute it, then actually x2, y2, if you substitute the point, and this will become 0 because the point lies on the circle. And even here also x2, y2, if you substitute it, then actually, so this equation is getting satisfied. Hence, we can state that this point lies on the first circle and also lies on the straight line. Hence, actually, as this entire sum is coming out to be 0, hence you can comfortably state that the point lies even on the circle given by s plus kl is equal to 0. So these are the three important conclusions we have made. One conclusion is the intersection, right? So the intersection point actually, if there is a circle that was drawn given by s plus kl is equal to 0, that will be a circle equation. That is one important aspect. And the second important aspect is, so the point actually, so the point of intersection of the original circle and the straight line and the derived circle all will have a common point of intersection. So these are the common points of intersection. Got it? So these are the two important conclusions we can make out. So as and when we have given a circle equation and we have given a straight line equation, then s plus some random constant k times of l is always a circle, and that circle passes through the intersection of the straight line and the initial circle. Got it? Any questions on this?